Hello everyone, and welcome to the show. It's August 2nd, Saturday, and I'm your host, Sanno Annie. Today, I'm super excited to pull a really cool, trending article from the archives for you all. It's all about making digital people, like in games or virtual assistants, move and gesture just like real humans when they talk. It's seriously amazing stuff. Let's dive right in. The title is, I'm a bit of a mouthful. Get ready for it. It's called GestureHYDRA, Semantic email. Speed gesture synthesis via hybrid-modality diffusion transformer and sim. Phew, that's a long one. And if you want to check it out yourself, the curl billis tats //rxiv dot or /2507.2272111. It's long. So what's the big problem this paper is trying to solve? Well, think about the characters you see in video games, or maybe virtual news anchor on the internet. They talk and their hands and bodies move, right? But a lot of the time, their gestures are, kind of vague. They just wave their hands around to the rhythm of their speech. But we humans, we do so much more. When we say, look over there, and we point. When we say, I have 3 ideas, we hold up 3 fingers. These gestures have clear meanings, or semantics, and they make our communication way more effective. Most AI systems are really bad at this. They might hear the word 5, but the character just keeps doing some random, generic hand waving. It makes them feel less real and a bit clumsy. This paper is all about teaching AI to generate gestures that actually match the meaning of the words being spoken. To tackle this, the researchers came up with a super cool system called GestureHYDRA. First, they realized they needed better data, so they created a brand new dataset called Streamer. They recorded live streamers because streamers are always using specific hand gestures, like pointing to the subscribe button, showing numbers for prices, or giving a thumbs up. This gave the AI tons of high-quality examples of speech and meaningful gestures linked together. Then built the GestureHYDRA system itself. It's based on something called a hybrid-modality diffusion transformer. Whoa, big words, I know. But basically, you can think of it as a super smart AI brain. The hybrid part means it learns from both audio as your examples at the same time, making it really flexible. But can even do cool editing tricks, like filling in missing parts of a gesture, or replacing a gesture you don't like. And one of the most awesome parts is the Munch-style injection. This lets the AI learn a specific person's unique gesturing style. So, instead of a generic robot, the digital human can move at the same flair and personality as a real person. But here's the truly genius part. Then synchronized retrieval augmented generation, or RAG for short. What happens if the AI generates a gesture, but it's the wrong one? For example, the audio says, click the lower right corner, but the character just shrugs. Well, GestureHYDRA has a backup plan. It uses speech recognition to identify the key phrase, like lower right. Then it searches its library of perfect, pre-recorded gestures and finds the one for pointing to the lower right. Finally, it cleverly injects this correct gesture into the animation at the perfect time. So it syncs up seamlessly with the speech. It's like having a director whispering in the AI's ear, making sure it never misses a cue. So, where could we actually use this incredible technology? The possibilities are endless. First, think about virtual influencers and video streaming services like YouTube. Imagine a virtual streamer who can interact with their audience perfectly. When they say, we have a special discount only for the top 10 viewers, their avatar could hold up 10 fingers and point to the screen. This makes them so much more engaging and believable than the ones we have today. Second, this could completely change interactive learning. Picture a virtual tutor teaching you a new skill. The tutor could say, first you turn this knob, and then press this button. And their virtual hands would perform the actions with perfect clarity. This would be amazing for everything from science labs to learning sign language, making online education feel way more hands-on and personal. And third, of course, is the world of gaming and entertainment. In video games, characters could have conversations that feel incredibly natural. Instead of using the same few recycled animations, their gestures would be generated in real time to match what they're saying. This would make game worlds feel so much more alive and immersive. The same goes for creating digital actors in movies, or for video conferencing systems, where your avatar could mirror your gestures with amazing accuracy. Now, how does this compare to older technologies? Well, previous methods were pretty limited. Many of them just focused on matching the rhythm of speech. The gestures would be in time with the audio, but they wouldn't have any real meaning. It was like they were just dancing to the beat, not understanding the lyrics. Other systems that tried to use semantic gestures were often unreliable, frequently failing to activate the right gesture at the right time. GestureHYDRA is a huge leap forward because it deeply connects the meaning of words to physical actions. And with its clever RAG system, it has a safety net to ensure high accuracy. The quantitative results from the paper show this clearly. On their own streamer dataset, their model achieved a semantic activation rate of about 85%, which was way higher than all the other methods, some of which were down in the 60s or even 30s. This means it gets the right gesture, right when it's needed, far more often. So in conclusion, this paper is paving the way for digital humans that don't just talk the talk, but can actually gesture in a way that's meaningful and natural and totally in sync. It's a huge step towards making our interactions with the digital world feel just as rich as our interactions in the real one. That's all the time we have for today, everyone. Thanks so much for tuning in. This is your host, San Noraini, signing off. Catch you next time.